Hello all, my name is Krish Nayak and welcome to my YouTube channel. So guys, welcome to the crash course of building generative AI application using AWS cloud. In this crash course, we will be seeing various AWS services and how we can specifically use them in order to build amazing generative AI applications. Not only that, we'll also go through AWS Bedrock services, which provides you various foundation models in the form of APIs without worrying about the inferencing part. And we will try to build end-to-end generative AI application using Langchain, and we'll also be deploying them. Not only that, we'll also be including Huggingface and how we can actually use Huggingface in AWS Sagemaker and how we can deploy the LLM models. We will be seeing all these things just to make sure that the effort is satisfied from my side. I will keep a like target of 2000 for this particular video. Please make sure that you hit like, and yes, put down your amazing comments. The comment target will be 200. In this video, I'm going to probably discuss about the Gen AI project lifecycle. Now, since you already know that we are definitely going to develop a lot of applications specifically in cloud from the basic data ingestion till the deployment. So it is very much necessary that you actually understand a generic workflow of the Gen AI project lifecycle. So let me quickly go ahead and write some amazing things for you in this particular notebook. And I will be explaining you completely step by step how you can probably see or follow a project lifecycle. And as we go ahead, there will be many things that will be coming, like LLM Ops platform. And we will be working specifically with Azure AI Studio, AWS SageMaker Studio and all. So definitely both the clouds will get covered. So before I go ahead, please make sure that you keep the like target of all this kind of videos till 1000. That will definitely motivate me. And I've been exploring many more things so that you get the right kind of guidance and knowledge. So let me go ahead and let me start the Gen AI project lifecycle. With respect to this Gen AI project lifecycle, I would like to make this entire lifecycle into 4 to 5 steps. Okay. The first step, that is nothing but, here I'm just going to write over here. It is basically defining the use case. Okay. So what kind of use case are you solving? Now, this use cases can be a RAG application, can be a text summarization application, can be a chat bot. So based on different use cases, that actually depends on your requirements, your company requirements. So this is the first step. You really need to define the use case that you're specifically doing. Now, with respect to this particular use case, we usually take this entire module into the scope part. Okay, so this is basically my scope, right? If I basically use a generic term. Now, once you define a use case, let's say that I am going to probably develop a RAG application. In that, I'm going to definitely use vector databases. I may have a lot of PDF files. I also need to probably convert that into a vectors and store it in some kind of vector store DB. So some kind of use case you really need to define and all the requirements that is required in that particular use case. Coming to the next step, which is super important, because these steps will be involving two important things. Okay. And that is nothing but choosing the right model. Okay. The right model. When I say choosing the right model, here there are two different things that you can probably split this into. One, whether you are using or you are probably using some kind of foundation models. So here I'm going to probably write whether you are using foundation model and solving a use case. So this is the one category that I would like to divide this particular module into. The other category is that whether you want to build your own custom LLM, right? Custom LLM. Now see, there are two things over here, right? When I say foundation models are already those larger models like OpenAI, Llama 2, Llama 3, right? You have Google Gemini Pro. So these all are very huge foundation models. And for most of the generic use cases, you can directly use those kind of foundation models and you can solve the use case itself, right? Now, with respect to these foundation models, we can also further go ahead and do fine tuning, right? So let's say I have a foundation model which I am specifically using to solve my business use cases. On top of that, if I really want to make this foundation model behave well for my own custom data, then what I can do on top of this foundation model, I can use LoRa, Clora techniques, and I can probably fine tune all these kind of models. Okay, so this is one of the step. The second step that I have written over here is custom LLM. Custom LLM is nothing but it is building your LLM from scratch. Building your LLM from scratch, right? And obviously, this one, there's a lot of benefit also if a company is building an LLM model completely from scratch for the specific use cases, but a lot of resources will definitely be required. We have to really take care of model hallucination, many things and all as we go ahead. But yes, I've also seen many companies developing their own custom LLM model. Okay, so choosing the right model or what kind of models you're specifically using to solve this particular use cases, that becomes the second important module with respect to this GenAI project lifecycle. And obviously, I've spoken about foundation models both in AWS you have, in Google you have, in Microsoft Azure you have. Currently, Microsoft Azure AI Studio specifically have all the access of OpenAI services. Obviously, it is investing a huge amount of money over there. Okay. Now, once you probably select the right kind of model, there are main 3 tasks that you probably do for going forward. Okay. So, main 3 tasks. Okay. The first task is nothing but you can specifically use prompt engineering and solve a use case. Prompt engineering and solve a use case. The second task that you actually can do is nothing but fine tuning, right? Fine tuning. So with the help of fine tuning also, you can probably develop your own custom LLM model, and on top of that, you can basically do it. Let's say you're completely creating your LLM model from scratch. One more important mechanism that you have is nothing but aligning, or you can probably say training with human feedback. And this is one of the very important step that is actually used while you're training your LLM models. How a LLM model is basically trained, I've already created a video in my playlist with respect to the Langchain and all, Generative AI playlist. You can probably go ahead over there. Fine tuning, how to specifically do fine tuning and all, that also I've actually shown you. The reason why I'm showing you this Generative AI project lifecycle, because tomorrow when I'm probably creating videos, or let's say in the upcoming videos when I'm creating videos related to AWS series, over there you'll be seeing all these particular steps going ahead. Okay. Now, once you probably do all the steps, the further step is something called as evaluation. Okay, evaluation is basically seeing that how your model is performing by performing all these particular steps. There are also different performance metrics which we are probably going to follow. Okay, these 2 steps I would like to combine and say something like this. Okay, so I'll say probably adapt and align models. Okay, so this will be the specific module that we specifically use for this purpose. Now, over here, your model will be ready. Everything is perfect. You are able to solve the use cases. Let's say your performance metrics is increasing over here. So your metrics is specifically increasing, and it is saying that now your model is ready. Now it comes to the deployment part, right? So with respect to the deployment part, I would definitely say deployment. Further, you also need to do a lot of integration with different applications. So I will probably say application integration. Okay. Application integration. And here what we do, we specifically perform 2 major steps. One, we optimize models. Okay. I'll just write optimize and deploy models. Optimize and deploy models. Okay. And this deployment is specifically done for inferencing. Okay. And here is where most of your cloud platforms, here is where your LLM ops is used. You know, different inferencing techniques are there. One technique I've already covered with respect to a platform which is called as Grok, right? It uses an inferencing technique which is called as LPU. So it is always good idea that you should definitely know multiple ways of inferencing. See, at the end of the day, whatever models you specifically create, unless and until the inferencing is not fast, you definitely cannot use those things, right? So it is very much necessary that you know the idea of this module extensively, because tomorrow building all these things is very easy. Fine tuning is very easy, right? You definitely have a template, a framework, a data set preparation and all, and you can perform this particular step. So that is the reason in this series of videos you'll be seeing that how much I will be focusing on this LLM Ops platform, right? And I will also show you multiple platforms like which can definitely make your inferencing very much good. So this is the most important thing here. Definitely we'll be using AWS, Azure, right? You can use all these things, GCP, and we'll see what all services they have specifically provided probably for the inferencing purpose again. But initially our focus will definitely be on AWS. Okay. Then the second step, after we do the deployment in the application integration, what we do next is that we build a LLM powered application. Because your integration is done, your API is created. Now it's all how well you can actually build the solutions. You can solve different use cases and all. So this overall gives a brief idea about the entire GenAI project lifecycle. Since we have already started this generative AI on cloud, so this is necessary to know, and you should probably follow all the steps. And whenever I create any videos with respect to GenAI on AWS, all the steps will be considered in mind and it will be shown to you. We're going to continue our generative AI on AWS cloud series. And in this specific video, we are going to develop an amazing end-to-end generative AI application using various services that are present in AWS cloud. I will give you a brief architecture, what we are going to implement, and then step by step, I will be showing you how you can use various services that are present in AWS and implement some amazing generative AI applications. So what we are going to probably do in this specific use case, this use case, I'm just going to keep it as block generation. So here you can probably see block generation is there. Initially, what we will do is that our main aim over here will be to create an API. Okay, so we will try to create an API. So we are going to use Postman to hit this specific API with some specific body. That body can include query. Okay, query from the user, like what blogs we need to probably generate. And as you know, in AWS, in order to create APIs, we use Amazon API Gateway. So we are going to also use this. As soon as we trigger this particular API, it is going to hit our Lambda function. What exactly is a Lambda function? We'll also understand about that. This Lambda function in turn will be interacting with Amazon Bedrock. Okay. Now, if you don't know about Amazon Bedrock, here all the foundation models will be available, right? Foundational models will be available. Like Amazon has a lot of different foundation models like Llama 3, Llama 2, it also has paid from Cloudy, Anthropic, specifically Cloudy models and all are there. We'll go ahead and see what are all these kind of foundation models and how we can specifically use that. And this Lambda function will be responsible taking up the query, hitting this particular foundation model and getting back the response. Once we get the response, in this particular case will be our entire blog, the 200 words or 300 words blogs that we are probably going to create. And finally, what we are going to do is that we are going to take that specific blog and save it in AWS S3 in the form of text file or any kind of files. Okay, we can also convert that into a PDF file and save it in Amazon S3 with the recent timestamp. Okay, so this is the entire thing that we are going to implement. And understand, this kind of use cases is even available in AWS documentation, and many companies are implementing the generative AI applications in this way. As we go ahead with respect to the series in the future, we will also be developing some amazing applications that are related to RAG, different document Q&A, how we can actually use vector databases. I will be showing you all those things, and we will try to use all the ecosystem that is provided by AWS Cloud. One of the important, you can probably consider that in most of the companies, they are specifically asking this in interviews. They definitely want you to say that how you can probably implement anything in AWS Cloud with respect to the generative AI application. So, so many different things we are going to go ahead and see. So first of all, let's go back to your AWS account. So initially you really need to have an AWS account and make sure that you have it. Then only you'll be able to use all those services. Now, first of all, what I'm actually going to do is that I'm going to go to AWS Bedrock and just give you an idea like how does all the foundation model looks like and what all foundation model is specifically provided by Amazon Bedrock. Okay. So first I will go ahead and click this, and here you can probably see that my Amazon Bedrock will get loaded. Once it is getting loaded, you can probably go ahead and click on get started. Now with respect to this, you can see over here, foundation models are specifically over there, and you can actually do chat, text, image. So it supports multiple models itself. Now which all companies model is basically there in this foundation model. Here you have A121 Labs, that's from Jurassic 2 series. You have Titan by Amazon, you have Cloudy by Anthropic, you have Command by Cohere, you have Llama 3, you have Mistral, you have Stable Diffusion. So you can actually work in images also, and you can generate your own image as you want, right? Let's say if I really want to use Llama 3, so I will go ahead and see this. Here we can probably see all these things are there, like Llama 2 13B, Llama 2 Chat 13B, and even Llama 3 is also there. I will also show you that. You can also go ahead and check it out in the playground, chat with it, and probably get it. Now the first step before we start all these things, right? Our first step is specifically to make sure that we have to take the model access. Understand with respect to different region, yeah, you will be having the access of different models. So you have to request for it. Okay. Here you can see that in my region, that is I have selected US East one. You'll be able to see that I've granted access to all these models. Anthropic Cloudy 3 models are not given because for this you really need to provide some use case details and then you have to submit it. Then the Anthropic will give you the access itself, like what kind of use cases you are basically doing. But according to mine, I have already, you can probably see that I've got this access granted. In order to get this access, you just click on manage model access, select which all models you specifically want as access, and just go ahead and click on save changes. Okay. I've already done that. So here you can also see that the save changes button is over here. So here you can probably see save changes is there. You can go ahead and probably click on this. What all models you specifically want, just go ahead and check it out. And then in some time you'll be getting the access model. Okay. The model access will be granted. So this is the first step that you really need to do. Okay. Now, once you specifically do it, then I will show you how you can go ahead and invoke all these kind of foundation models and how you can go ahead. Okay. So this was one of the services that we are going to use. The next services is specifically Lambda function. What exactly is Lambda function? We'll try to understand. So yeah, here I will go ahead and search for AWS Lambda. So here you can see what is Lambda console in AWS. Quickly to test an event. It is a serverless managed application in. Okay. I will just go ahead and search what is AWS Lambda. Okay. So if you probably go ahead and see the definition with respect to AWS Lambda, it's saying that run code without thinking about servers or clusters. See, instead of AWS Lambda, I can also use an EC2 instance in AWS and then probably set up all the things, install all my requirements over there, set up all the libraries, develop my entire application, and then probably with the help of API gateway, I can probably interact with that. And within that EC2 instance, I will try to invoke my AWS Bedrock. That also you can probably do. And in the upcoming examples, I'll also show you that if you want. But right now we are going to use AWS Lambda. So AWS Lambda is a compute service that runs your code in response to an event. So suppose if I hit an API, this is going to get triggered and then it will go ahead and call the AWS Bedrock. So the benefits of Lambda is that no need of managing servers. It is automatically scaling and you have to probably pay as you go, like based on the number of requests, and then performance optimization will also be taken place in the AWS Lambda itself. Many companies specifically use that. If you have a smaller application, you can definitely develop this. So let's go ahead and let's try to see that how we can go ahead and work with AWS Lambda. So here you can probably see AWS Lambda. As soon as I click on AWS Lambda, this will get opened. Here you can create multiple functions. I've already created one function. I will show you how to create this. So let's go ahead and create the function over here. So as soon as I probably create the function, here you can see I can select author from scratch, use a blueprint, container image, whatever things you specifically want. Here what I'm actually going to do is that I'm going to give my function name, and my function name, what I can do over here is, let's say I'll give my AWS app, okay, with Bedrock. Okay, so this will basically be my AWS function name, Lambda function name. Runtime, I will go ahead and use Python 3.12. just to make sure that I have the recent updated Python. And along with that, whatever by default is there, you can go ahead and select that. But here I'll just keep it since we are developing it for the first time. And I'll go ahead and click on create function. As soon as I probably create the function, here you'll be able to see that my AWS app Bedrock Lambda function will get created. And again, this takes time, some amount of time based on the internet speed and the kind of application that you're developing. So here you can see that it has got created, AWS Bedrock. I will show you, here are some options like layers, add triggers, add destination. Now see, my main aim is that as soon as I probably create an API gateway, right? Because I need to hit the API, then only this function should get triggered, right? Inside this function, I will write my entire code, how to invoke the Bedrock, AWS Bedrock foundation models and all, right? So if you go down here, you'll be also able to see some amazing things like code, test, monitor, configuration, aliases, version. So if I go ahead and click on configuration, here you can see there is some timeout configuration that you can probably give. There are some environment variables if you want to probably give, you can also give it over here directly. Environment variables, I hope I've shown you in VS Code. We create a .env file, we create a key like OpenAI API key and all. Here also you can probably write it down and you can call that OpenAI key in this particular code. So one general configuration, what I will do is that I'll keep this timeout to 3 minutes because just to keep it in the safer side so that it does not get hampered over there. And here I'm going to write my entire code. Okay. Now, before I write my entire code, whatever code I'm going to write, I'll be writing over here. But again, this does not look very comfortable writing the code because here I will not be able to get much suggestion with respect to the code. It is better that I write this entire code in the AWS in my VS Code, and then I'll copy and paste it over here. Okay. So what code I'm going to write it down over here, I'll be showing you that specific code with respect to this. Okay. So let me just go ahead and open my VS Code over here. And here is one of my, I will just open my terminal. Okay. Oops. Let me just go ahead and open my terminal. And I'm going to write my code completely. Okay. Command prompt. So first of all, I will just go ahead and create my environment. So let me just go ahead and write conda create -p VNV environment Python. As you know, I have taken 3.12. Okay. So this is the environment that I'm going to create because I'm going to write my entire code over here with some requirement.txt and all. So let me just create this. I'll create one file which is called as requirements.txt. So whatever is required for my project, and that I have to actually put it in my Lambda function, all I will be writing it over here. Okay, so requirement.txt. Let's wait till this entire is getting created. So here you can see a new version of this, and I will just go ahead and click on yes. And automatically my entire conda environment will get created. So there are two important things that I'll do. First, let me go ahead and write the code for this. What all things I actually require, I'll be writing it. Let me create a file also, app.py. Okay. In requirement.txt, the first library I actually want is nothing but Boto3. So I'll keep this Boto3 like this, and whatever is the recent version of the Boto3, that is only supported by Lambda function. Okay, not the previous one, because the recent version of Boto3 has lots of functionalities to invoke foundation models from AWS Bedrock. Okay, so you should know all these things. Okay, so let me quickly go ahead and write my code now over here. So first of all, I will go ahead and write import Boto3, and I'm just going to write import Boto core dot config. Okay, so this is two important libraries that we specifically use. Understand, Boto3 is used to invoke the foundation model. Okay, so here I will just go ahead and do one thing. Okay, so let me just go ahead and see, this is my VNV. I will just go ahead and activate. So conda activate VNV. Along with this, what I'm going to do, I'm going to just write pip install -r requirement.txt so that my Boto3 gets installed at any point of time. Okay, so this installation will take place. Let it take place. Till then, I will go ahead start writing my code. Okay, now what I'm actually going to do, my main aim is to create a blog, right? I really need to write a blog. I need to create a blog, and for that, what all things I will be doing, I'll be showing you step by step. Let me just do one thing. I will keep my notepad over here. The reason why I'm keeping the notepad, so that Step by step, I've from the documentation, I've taken all the steps, what is basically required, and when we have to create what services needs to be created and all. I will be writing all those things, right? So I will create a function which will basically be called as definition blog underscore generate using Bedrock. Okay, so this will basically be my function name. And when I create this function, I will also use this. I will give my query or message or what blog topic. I can also basically say blog topic, and this will basically be a string. And this will also return a string. Okay, this will also return a string, right? So this will basically be my function which will generate the blog. Here, what kind of blog I'm going to use, that I will be discussing. Sorry, what kind of foundation model that I'll be using. So first of all, let me just go ahead and create all my prompts. Since I'm going to create a multi-line character, so I will go ahead and write this and create a blog, okay, over here. Okay, so sorry, my prompt. I'll write my prompt. And before I write my prompt, let's go and see which Amazon Bedrock model I will be specifically using. Llama 2 Chat 13B, I can specifically go with this. And here you can probably see this is my model name, okay, model ID. Okay, you really need to remember this because these are all the things that I really need to give. The content type will be application/JSON, and body. This is the most important thing. What is the prompt that I am going to probably put over here? What is the other information that you basically provide with respect to the body, right? So this all information definitely you really need to provide. Similarly, if you go with Llama 2 Chat, Llama 2 Chat 70 billion parameters. So here you can see this is where you place your input text. Okay, and similarly, if you go ahead and explore Llama 2 13 billion, you can also see other information with respect to. So each and every model, how the API request should be, you should be able to get it from the AWS Bedrock itself. Okay, so all the information are specifically over here and you can basically check it out, right? So whatever model you want to use, okay, you have to make sure that what API request is specifically there. Based on that only you have to probably create everything. Okay, now what I'm actually going to do is that I'm going to create my prompt. Okay, now in this specific prompt, I'm going to basically write an S character, and let me just go ahead and provide like this S. So the first thing is that I will be using this keyword inst. As you all know, in Llama 2 models we specifically use. I will go ahead and write human. Okay, and human is basically giving this particular query. Okay, I'll say write a 200 words blog on the topic, and the topic will specifically be my blog topic over here, which I will be giving from my input, right? Whenever I hit that particular API. Okay, and after this, what I can actually do is that as soon as I give this particular instruction to as a human being over here, the next thing is that I will have my assistant, right? And now I will go ahead and write about assistant, and this will basically be closing the inst. This is the keyword that we specifically use for most of the Llama models, right? So very simple, write a 200 word blogs on the blog topic, and this will basically be my assistant. Now, as I said, I have to worry about the body. Now, my body has what all things, right? You really need to go ahead and check it out from here. My body has a prompt message. It has a maxgen length message. It has a temperature message, and it has a top_b. So these all parameters I really need to set it up. So quickly, I will go ahead and write it over here. So first parameter will be nothing but prompt, and this will basically be my prompt_text. Okay, so sorry, I've not created my prompt yet. Okay, this will basically be my prompt. Okay, now after I will probably define my prompt, the next parameter that I have already written is nothing but max_gen_length. Okay, and this will basically get assigned to 512. Okay, and then you can probably see this will basically be my temperature variable, which will be my third parameter in my body that I will be sending. And another one will be top_p, which is another parameter that is specifically required in my body. So this basically becomes my body. Now also what I am actually going to do is that with the help of Boto3, I'm going to call this foundation model. So that is my Meta Llama 2 13 billion chat model, and then further things I will try to go ahead and do it. Okay. Now before I call that particular model, let me just go ahead and create a try catch block, so that it is always good that we really need to have a try catch block, so that whatever errors we specifically get. So I will go ahead and write Bedrock, and let me go ahead and write boto3.client, and here I'm going to basically call Bedrock underscore runtime. And if you have already seen my Bedrock videos, I've already shown you how you can invoke the Bedrock. We have to specifically create the runtime. The region of all the foundation models that I'm actually going to call will be nothing but US East 1. Okay. So this is the region that we are specifically going to use. And the next thing that I'm actually going to give is my config. So inside my config, or let me write it like this. So this will basically be my config. Inside my config, I'm going to use my botocode.config. And here I have to set up some of the parameters, right? Read timeout. Okay, read timeout. And here I'm going to probably take up 300 seconds. And I'm also going to give one more parameter, which is nothing but retries. Okay, and this will basically be retries, and this will be set to a variable which is called as max attempt. Max underscore attempts will be nothing but it will be 3. Okay, so here I'm going to keep up all the values. So these are the basic configuration that I am specifically giving with respect to my number of tries, so in short, this variable will be used to call my foundation model. Okay, now in order to call the foundation model, I will write bedrock dot invoke underscore model, and here I'm going to give my body. The body is nothing but I'm just going to write json.dumps. Okay, json.dumps, and again I have not imported JSON, so let me just go ahead and do that. So I'm going to write import JSON. Okay, so once I probably write import JSON, so here a json.dumps, and here I'm going to probably give my entire body. Along with this, I also need to call which model I'm basically calling. So for that, I have to mention my model ID, and this time the model ID is nothing but you have to refer it from here. So this is nothing but meta 70 billion. Let's go with 30 billion, because the request, again, I have to pay based on the number of requests that is probably going, right? So model ID here, I'm going to just paste it, and I'm calling the 13 billion chat v1 model. Okay, so once you do this, then what we can do, we will get our response underscore content, and let me just go ahead and write response.get body. So for that, response underscore content, response.get, and here we are going to basically write body dot read. Okay, dot read. So we are specifically going to read this specific response. And one more thing that you can do, right? And understand one more thing, guys. Very simple. Whatever response you are probably getting, I will just go ahead and import the response also, because I will be using this. Okay, so response.get body.read. Once I read that particular data, what it will happen is that I will just go ahead and load this with respect to my response underscore content. Okay, now here you should understand, right? When I invoke this particular model and when I give my body over here, I'm basically calling this particular model over here itself. That is my Llama 2 13 million chat v1. And then with respect to this particular body, whatever body we are specifically getting, we'll read that particular response. And let me do one thing. Let me just make this particular spelling correctly. And as soon as I load this particular response content, let me go ahead and store it in my variable response underscore data. Okay, now once I load this, let me just go ahead and print it if I really want to see my response underscore data. Okay, if you want to probably see it, this response will be having a variable. Understand one thing, that whatever response we are basically calling, it is giving the response from our entire model, the model that we are using, the foundation model. And now here I will go ahead and write, this will basically be my blog details. Okay, blog details, and this blog details will be available inside response underscore data with respect to my key variable, which is called as generation. So this model, whatever response it is basically giving you, it will be saved in this particular key variable within your response data, which has been converted into JSON. And when you write response.getBody.read, in short, you are basically getting the response from this. Okay. And finally, I'm going to return the blog underscore details. So this function here you can see, and let me just go ahead and write my except block also. Except exception. I'm just going to create my exception as E, and we are just going to print the errors. And understand one thing, guys, whatever printing that we are specifically doing, AWS Lambdas make sure that all the logs will be logged in the CloudWatch logs, right? So that is also very good advantages for you, so that you'll be able to see that. So errors generating the code, error generating the blog, and I can probably display this particular error, which is basically over here. And let me return it with a blank string. Okay. So here we have basically done almost each and everything. We have displayed the data. This is the blog details that we are specifically getting. And this is the function that is responsible in generating the blog. Okay. Now let me quickly go ahead and do one more thing. Let me go ahead and see, by default, if I go inside my Lambda function, it has a function which is called as Lambda handler. Okay. So let me just go ahead and define this Lambda handler, because my API gateway, whenever it sends any post event, it will be captured from this particular trigger, and it will hit this particular function first. So we have to capture this event along with the context, and then we can probably retrieve whatever query we are specifically giving. See, here we are giving the blog topic, right? That blog topic will be captured in this specific event. Okay. That is what is my plan. Okay. So here what I'm actually going to do, I'll just go ahead and create my event. So event json.loads, and I will take this event, and let me do one thing. Let me keep a variable, right, which is basically called as body, because whatever post request we are sending, this will be available in the body key itself. Okay. You'll be able to understand it. And then this will basically be my blog topic. So let me go ahead and write my blog topic. My blog topic will be nothing but, I will just go ahead and write event of, I can keep a variable called as message, or I can also keep a key called as blog. So you'll be able to understand inside this body, I will be giving in a JSON format where my blog topic will be in this particular variable name. Okay. So blog underscore topic. Let's say here I go ahead and write blog underscore topic is equal to machine learning. Then I should be able to get this. Okay. Then once I probably get the blog topic, then I will go ahead and write generate underscore blog. And now I will go ahead and call my generate blog using Bedrock. Okay. So this will basically be my function. And here I'm going to probably give my blog topic name, which will be nothing but it will be your blog topic that I have actually created. So in short, this function, when I'm calling it, it will be responsible in giving me the entire blog by calling this particular model, that is Llama 2. Okay. So once I probably get this generate blog, now I'm going to go ahead and write if generate underscore blog. Okay. Now, as you know that I'm going to save this particular blog in my S3 bucket. Okay. S3 bucket, the reason why I'm saving it, I'll try to save it in a txt file so that I will be able to access it whenever I really want. So let me do one thing. Let me go ahead and import from datetime. I'm going to import datetime. Okay. So the reason why I'm importing this datetime, because I really want to create all the txt file in a way where I consider the current time. Okay. So current underscore time is equal to datetime dot now, and here I'm going to use dot strf time in the form of hours, months, and hours, minutes, and seconds. Okay. And then I will go ahead and create my x3 key name. Okay. S3 bucket key name, So s3 underscore key, how my file needs to be saved. Okay. So I'm going to create an f string, and let me just go ahead and create something like this, blog output folder. So this will basically be my blog output folder. And inside this, I will go ahead and write current underscore time dot txt file. Okay. So this will basically be my txt file, which will be saved in that particular s3 bucket. Now let me give my s3 bucket name. So s3 underscore bucket name. And let me go ahead and write AWS Bedrock course 1. Okay, so let me create this particular Bedrock name. Okay, and now I've given all the information. Now I can call a function. Okay, and let's say first of all, let me just close this if clause. So here I'll say print no blog was generated, right? No blog was generated. Perfect. Now the next step, what I'm actually going to do over here is that once I get my key and bucket, I should be able to call another function. I'll create another function, and let me go ahead and write this particular function. And here I'm going to write save blog details. Okay, in S3. Okay, so this will basically be my function. And with respect to 3, I require 2 information. One is my S3 key, and the second information is my S3 bucket. Okay, so in short, I'm taking up all this particular information, and here you can actually see that I'm saving it in the S3 bucket. Now the further code, I can probably write it over here. Again, over here, what I will do, I will go ahead and write boto3.client. Okay, so this will basically be my boto3. Let me see, I've imported boto3 or not. So this client will be nothing but my S3 bucket. Okay, and again, here I will go ahead and create my try catch block, and I will say that, hey, go ahead and create s3.put object is nothing but with respect to my S3 bucket, S3 key, body also I need to save it, and the body will be nothing but let me just see over here. Okay, body will be nothing but whatever is one generate blog that I'm actually getting. Okay, so here I will go ahead and give my generate blog, which will be assigned to this. Okay, so in short, I'm taking my entire information blog that is generated in this particular bucket with this particular file name. So here I'm going to probably call this function that is nothing but save blog details. And with respect to this particular save blog details, as I said, I require s3 underscore key. The second parameter that I require s3 underscore bucket. Okay, and the third parameter I require is nothing but my generated blog, which will be in this specific name. Okay, so done. This is good enough. Everything is probably given over here. But again, understand with respect to Lambda handler, I should be returning something, because once the execution is done, just for my verification, I will be returning something like a status code if there is no error. So I will set up a status code, which will be nothing but it will be equal to 200, and body will be equal to json.dumps, and I'll say blog generation is completed. Okay, just to get me a message. Okay, so done. This is good enough. I've got each and everything over here. It looks absolutely fine. With respect to the functionalities, whatever is required, I have actually given it over here. And this looks absolutely fine with respect to whatever information I see over here, right? And again, understand, okay, this response variable, I will save it over here. Okay, so since I'm hitting this particular Bedrock and this response, I can remove it. Okay, so that is those variables. So let me quickly copy this and let me do one thing. Let me paste it completely over here, right? So here I'm just going to paste it, and this will basically be my entire Lambda function with respect to all the details and whatever things I specifically require. Again, to write it over here, it would have been difficult, but now there you could see that how easy it is, right? Now we'll go ahead and click on deploy. Okay, so once this is probably deployed, I can go ahead and create my API gateway and all. Okay, one more important thing, understand that this Lambda function requires a recent version of Boto 3. And if you probably go ahead and see what default Boto 3 version is basically present in this Lambda is the older one. Now, in order to create or have a new Boto 3 library installed, what you really need to do, Okay, so here you can see, I'll be showing you one very important thing. I've actually created a zip file. Okay, so you have to probably follow this step. Okay, and this will basically be helpful for you. Okay, let me do one thing. Let me just remove this. Okay, so here you can probably see I have created a folder which is called as boto3_layer. Okay, now understand one thing, what I am actually doing over here. This is important for you all to understand. Okay, unless and until you don't understand this. So I will go ahead and activate my VNV environment, or okay, VNV environment is not there. Okay, what I'm actually going to do, see over here. Okay, conda deactivate. Okay, now understand one thing. As I said, my lambda function requires a new version of the Boto3 installed. See, whenever we open a lambda function, by default the older version of Boto3 is there. Now in the older version of Boto3, because at that point of time you did not had Amazon Bedrock, all the foundation models, right? So what we need to do is that we need to update the packages with respect to the Boto3. Now, how do you do that? Okay, how do you do that? And this I would definitely explain you in a better way. See, what I have done is that I've created a folder which is called as Python. Okay, now inside this Python, what I have actually done, see, it is very much important. Now inside this Python, I have installed a library which is called as Boto3. So if you probably go ahead and see this, right, here you'll be able to see Boto3, Boto Core, all the information is specifically there, right? Now, this will be a task for you. Just tell me, how can you install a library inside a folder? Okay, just to give you, pip install Boto3 -t, right? And if you go ahead and write this, right, what it is basically going to do is that the entire Boto3 library will get installed inside this particular folder. And once this folder is created, what I can do, I can make sure that I will go to this particular folder and I will make a zip file. You can compress this particular file and you make a zip file, and you can name anything. Here I have given boto3_layer.zip. Okay. If you want to install any packages in Lambda, first of all, you really need to create a Python folder, install all the packages that you want. Let's say by default over here, if I go ahead and write import pandas may not be installed in Lambda. So if you really want to install pandas, what you really need to do, inside this Python folder, you will go ahead and write pip install pandas -t Python folder / automatically the installation will take place, and then you convert into a zip file. The zip file name can be anything, but inside the zip file, there should be a Python folder with all the packages. Okay. So I'm going to specifically use this. Okay. So I have created over here boto3.layer.zip. Now I'm going to go down and let me do one thing. Over here, you'll be able to see layers. Okay. So I'm going to click on layer, add a layer. Now inside this particular layer, this basically says that if you really want to add any kind of packages, you can add it in the form of layer. Okay. So here you can see AWS layer, choose layer, custom layers and all, specify a layer. So what I'm actually going to do, I'll just go ahead and select my custom layer. See, over here, you can also create your own layers also, right? You can create your own layer information. So one of the layer you can probably see over here, it is written as Boto3_bedrock. And this is the layer that I've already created. Okay. Now, in order to create the layers, I can go ahead and click on this particular layer. I'll go back. I will click on create layer. See what I've done. So, okay, this is my Lambda function. Understand this thing. Okay. If I probably show you my functions, this is my function. Okay. Now, I've already written the code. I've deployed that particular code. Now, what I need to do is that I need to create a layer, right? So that I update all the packages. Okay. So in order to create the layer, I will just go ahead and click on add a layer. And over here, what you do, just go back to this particular layers and click on create a layer. And here I will go ahead and write Boto3 updated layer. Okay. And description I don't want. I'll upload a zip file. I hope everybody knows where the zip file is. So this is my zip file. So I will go ahead and click on upload. Okay. And I will take this path over here and I'll paste it. Okay. I will go ahead and write Boto3_layer.zip. Okay. And then there is also like which all version you really want to be compatible with. So I'll go ahead and write Python 3.12, Python 3.1, Python 3.10. Okay, so these all layers I really want to put that, okay, it is compatible with. And now let's go ahead and click on create the layer. Okay, so once this particular layer is basically added, created, then we can add this particular layer to my Lambda function. And this is just to make sure that all your packages are up to date. That is the main reason why we are specifically doing it. So it is going to take some amount of time, again, based on your internet speed. And based on that, we will try to see that what all things we can actually do. Okay, so let this thing get created and let me have a look with respect to this. Once it is getting created, okay, now this looks that it is created. Now I'll go to my Lambda function. Okay, create a function. Let me go back to my function. This is my AWS Bedrock. And let me go ahead and now add a layer which I have already created it. Okay, so now it should be my custom layer. I will go ahead and select this Boto 3 updated layer version. I can probably give it as 1 and click on add. Okay, so as soon as I probably give as add, you will be able to see that over here my layer will get automatically added. So one layer has got added. So my code is ready, my layer is ready. Now all I have to do is that I have to probably go ahead and create my API gateway so that it will get triggered or integrated with AWS with my Lambda function, and I will be able to trigger things. Okay, so now I will go ahead and call my API gateway. So API gateway is over here. This is how my API gateway looks like. Now let me do one thing. Let me quickly go ahead and integrate this API gateway with my Lambda function. Okay, so now my API gateway is opened over here. Now quickly let's see this. As soon as I probably get this particular API gateway, I will go ahead and integrate it. And then whenever I trigger this particular API, it should be hitting my Lambda function, which is in turn interacting it. So I will go ahead and create my API. And here you can see I will be using an HTTP API. Over here, you will be able to see should we add an integration, my API name and all are there. Let me just give my API name. So here, Bedrock demo API. I'm just going to write it down. Review and create. Okay, I will just go ahead and create it. Okay, now once I create it, after that I will start adding routes. So here you can probably see I'm getting routes over here. So let me just go ahead and create some of the routes. So here I will go ahead and write post request, and here I can go ahead and write blog generation will be my API. And let me just go ahead and create over here. Let me select this post. Here there are two options. One, authorize this, protect your API against unauthorized request. So if I really want to keep some kind of key for authorization purpose, I can do it. I can basically attach it over here. But right now, I really want to show you that how the post request will basically get handled. So here I'm going to basically attach integration right now. So attach integration, I will go ahead and click on. And with respect to this attach integration, I'm going to attach to my Lambda function. Now inside my Lambda function, I will go ahead and choose my Lambda function. So here you can see AWS app Bedrock. This is the Lambda function that I've actually created. And let me just go ahead and click on create. So once I probably create this, here you'll be able to see that my Lambda function is done. Okay. Now, the most important thing. Okay. One thing is that here, this particular API, I can also deploy to multiple cloud platforms. And see, whenever we do a bigger project, there is dev environment, there is QA environment, there is UAT environment, there is production environment. So similar kind of environments also you can create. So for that, just go to the stages. Okay. And by default, this is basically the default stage, but I will just go ahead and create my stage name. So I'll write dev environment, and I don't need to add the stage variable and all. So I'll just go ahead and create. Okay. Now inside this particular dev environment, you'll be able to see that here, right? Okay, let's see this. So this will basically be my URL, and along with this URL, if I really want to call my API, so this will basically be my URL. So I'll just go ahead and deploy it. So no stages found. Let's see. Okay, dev is there. So I will just go ahead and deploy it. Okay. So I'm deploy this entire URL, and this is the API that I have to specifically use for interacting with my Lambda function. Okay. This / whatever will be my route name, I can actually use it. So this, if I go ahead and I'll copy this also. Okay, just a second. I will just copy this. Okay, it has gone to this. Okay, no worries. I'll go back to my API gateway. And here now you'll be able to see all the API gateways that I have specifically created. I have also integrated with the Lambda function that is available over there. Okay, and this is how the entire interaction will take place. See, it's more about writing a code, understanding about each and every services, and that is why all these things are amazing, right? So recent date is 9th. So let me just click on this. Okay, post over here. I've already deployed this. So let me do one thing. So this is the slash blog generation. If I probably go ahead and see with respect to stages, if I go ahead and click on dev, so this will basically be my API. Okay. Okay, done. Each and everything is done. This is integrated. This is in turn integrated to my Lambda. Now, one thing that I have to do is that I also have to create my S3 bucket. Still, I have not created my S3 bucket because with respect to the code that I have actually given in my AWS Bedrock, my S3 bucket name should be, let's see what is the S3 bucket name that I have to write. So it should be AWS Bedrock course 1. So let me quickly go ahead and create my AWS Bedrock course 1. So I will just go ahead and create my bucket, and let me just go ahead and write my bucket name. Okay, and just let me go ahead and create the bucket. Okay, so this is the new, and understand one more thing, guys. This AWS Bedrock course 1 that I'm basically writing, the name should be unique. Okay, so this is the name that I'm actually selecting, AWS Bedrock course 1. Okay, and let me just go ahead and create the bucket, because throughout the region it has to be unique. Okay, now let me just go ahead and update in my name over here in my S3 bucket name with respect to this. Okay, now I'll just go ahead and deploy it. So my AWS S3 bucket is also created. The code is written where we really need to save all the files and all. Everything is ready. Now let's quickly go ahead and test it, and I hope everything will work fine. So I'll just go ahead and open my Postman. Okay, create my new file. It should be a post request. Let's see. I don't know whether it should work. Everything should work or not. If I'm getting any errors, definitely I'll let you know. So let me do one more thing. Let me just go back to this. So this is the URL I've already seen. I've already deployed it in it. Let me do APIs, block demo APIs. So this should be slash blog generation. Okay, so this will be my URL. I'll go back to my Postman, and you have to be patient, guys. Understand, you have to really be patient because there are multiple things that you'll be able to see. Now let me just go ahead and set up my body. My raw body will be with respect to one key. And if you probably see the Lambda function, what is the key name that I've actually created? Let me go ahead and see it. I'll open the Lambda function. And once I open the Lambda function with respect to my function name, AWS Bedrock. Okay. And here down, if you probably go ahead, come on, load it quicker. Come on. It's taking time to load. I don't know why. So code is getting loaded. I've already deployed this code also. You also have to deploy the code in order to use it. Okay. So Lambda function is getting loaded. Let me see. This is there. This is there. Okay. Over here, you can see this will basically be my block topic in the body. So let me just go ahead and write block topic. And let me just go ahead and write the block topic will be machine learning and generative AI. Okay, so this will basically be my key name inside my this entire thing will be a event. It will be in the event itself. Inside that event there will be a body variable, and then we will be able to explore this blog underscore topic. Okay, so let me just go ahead and click on send. Hope so it works fine. So it is hitting till then. Message not found. Why it is saying message not found? Because blog generation is there. Let me see. Blog generation. Let me see it. Blog generation. Let me go back to my API gateway. And for this also, what I can actually do is that go to my configuration, go to my monitor. And inside that, I can also see the logs, and it will be available in the CloudWatch. So here you can click on view CloudWatch logs. And here is my entire CloudWatch logs that you'll be able to see. Okay. But right now it is not working. Let's see why it is not working. We'll have the complete details that will be available over here. Now I goes to my log groups. Inside that groups specifically where we are actually working with. Again, I'm not going to delete this entire part of the video because I really also want you all to see the logs. Okay. To specify log does not exist in this particular account. Why? Okay, the logs has been not created. Let me just hit it once again. Blog underscore topic, message not found, status 404. I think so. There is some problem with my API gateway. Stages slash blog generation. Is it correct? Slash blog generation. This looks fine. My post request is this one. The integration in the background was save the request. Let me just go ahead and see my stages. My dev stage is this one. FPH. Let me see whether I've deployed that or not. Deploy. Successfully created deployment. The deployment is active for dev. This looks absolutely fine. Now let me just go ahead and hit it. FBH, this one. Message not found. Still message not found. Let me see that what is the problem in this. So guys, one simple mistake that I've actually done over here is that, see, when I pasted this entire thing, right, there was an extra space that was added. And Postman does not resolve this particular space, and it keeps the space like that. So I'll just remove the space. Now I'm going to search for the topic on generative AI. So I will go ahead and write this 200 words blog. Now let me just go ahead and click on send. And here you can probably see blog generation is completed. Let's see whether everything has worked fine or not. I'm just going to reload this log groups, and obviously you know how to go to this particular log groups. Go to configuration. Okay. Sorry, go to monitor and just click on view CloudWatch logs so that you'll be able to see the logs itself, right? Now let's see whether the logs will be able to see the buckets also or not. I'll also go ahead and check the buckets. So AWS Bedrock. So right now nothing has got created. So I think there should be some kind of error over there, but we'll have a look whether there is an error and we'll try to fix it. Okay. So all the things usually happens over here. So here you can see AWS app Bedrock, and there is one log. So with respect to this particular log, let's see AWS Bedrock, no blog was generated. Generating the blog, an error occurred when calling the invoke model is authorized to provoke invoke model and resource this because no identity based policies allows the Bedrock invoke model action. So guys, from the error that you probably see over here, it is not provided, it is basically not providing you the access. So definitely the role that we have actually created for a Lambda function, right? We really need to change over here, right? So what we can do, see, initially it was in code, right? Now let's go back to the configuration and select the role name. So if we select the role name over here, okay, let me just go ahead and select this. And now within this particular role name, we can provide further access to it. Okay. So let's say over here, only the AWS Lambda function is basically there. So what I can actually do is that I can provide more access, more permission policies so that I will also be able to access the AWS Bedrock. So to see like what kind of policies we can probably provide it, you know, and over here right now, what is basically provided only AWS Lambda. So let's see that how we can still add more permission. So here what I'm going to basically write, I'm going to basically select add attach policy. And again, based on like how your IAM console basically runs, right? I will basically provide it the administrator access. Again, if you're specifically working in the company, you can provide different access based on the services that you're using. But just to give a brief idea about it, so what I'm actually going to do is that I'm going to add this particular administrator access so that you'll be able to see that particular access over here. Now, once that is added, let me just go back over here and let's see whether it is updated or not. So I'm role, this is there. Okay, perfect. Everything works fine. So let me just reload this. And now I think we should be able to work out and see that, yes, now we'll be able to get the access. So here you can see all access is basically given. Now I'll go back to my Postman and again hit the same request. Now let's see if it is taking more time, right? That basically means my entire application is working fine, and we are able to see that yes, it is taking more amount of time. Now I think our blog will be generated, 200 words blog will be generated, and we should be able to be storing that entire TXT file in S3 bucket. So let's see. I will go again back over here, again reload my CloudWatch. So let's see whether my CloudWatch has basically created or not. Yes, new log has been created. So here is my entire blog that is got generated. Generative AI, the future of creativity and innovation. Here you can see everything is working fine. Code saved to S3 bucket. I can also see in the logs. Now it's time that let's go into my S3 bucket and see whether I will be able to find it out or not. So I will go back to my S3 bucket. Let's go ahead and hit this, and then I will be able to see this AWS Bedrock course 1. And here is my blog output, and here is my text file, right? If you want to probably see this particular TXT file, I'll just download it. But usually when we are working with AWS services, we can probably see that. And here, let me open this, and here is my entire blog, right? And this specifically, we are using the Meta Llama 2, 13 billion parameters. Generative AI is a revolutionary. All the blogs has been generated. So guys, we are going to continue our generative AI series on AWS Cloud. And in this video, I'm going to probably show you how you can actually deploy your Huggingface model. Let it be an open source model or any LLM models also, specifically in AWS Sagemaker, that is Amazon Sagemaker. Amazon Sagemaker is one of the important services in AWS where you can probably complete the entire life cycle of a data science project or an AI project completely, along with MLOps till the deployment, each and everything. So in this particular video, I will be showing you how we can take up any Huggingface model in short and probably deploy it in the Sagemaker itself. So please make sure that you watch this video till the end. And one more very important thing, guys, just check out this particular video. There may be some amount of charges that may incur. So please be careful with respect to this. Whenever you start creating, and finally, when you create that particular endpoint, make sure that you delete all the endpoints itself. And I will be providing you the entire guidance as we go ahead. So first of all, we are just going to go ahead and search for AWS SageMaker. And to start with, how to probably work with AWS SageMaker Studio and all, I will also be talking about that. So first of all, you can see, you can just go ahead and click on getting started. Okay. And with respect to this AWS SageMaker, the documentation is pretty much amazing, right? So if you don't know about AWS or Amazon SageMaker, it provides machine learning capabilities that are purpose built for data scientists and developers to prepare, build, train, and deploy high quality ML models efficiently. So what we are going to basically do is that step by step, I'm going to actually show you. So I'll go to the domain part, and I will go ahead and create the domain. So once I probably go ahead and create the domain, so here there are two options. One is setup for organization and the other one is setup for single user. Okay. So as soon as, and right now we are just going to test it for single user. So what I'm going to do is that I'm going to select this. Here you will be able to get an IAM role. Automatically it will be creating it with this Amazon SageMaker full access policy. Public internet access, standard encryption, SageMaker Studio, you'll get the access to this. You'll be getting shareable SageMaker Studio notebooks, SageMaker Canvas, and IAM authentication. So each and everything by inbuilt, it will be providing you this entire environment where you can actually do the coding. So just go ahead and click this. So once you probably go ahead and click this, you will be able to see something like, okay, the setup is going to take place. And it is going to take some amount of time, again, it depends on how much time it is probably going to take over here. It will automatically create the users and everything you'll be able to get it, right? So here, if I probably go ahead and just reload this, you'll be able to see that my third domain is probably over here getting set up. Pending is this, and it will probably take some amount of time based on the usage. But other than that, you can probably see that I've already created two. So since this is already getting created, I will just go ahead and show you some more examples with respect to this. So let me just go ahead and quickly click on this quick setup domain. You'll be able to see that by default, it will be creating a user. Okay. You can add any number of users based on the organization that you're specifically working in. Let's say you want to provide access to multiple users in the same domain itself, you can also provide it. Okay. So by default, as soon as you provide the user access also, there is one very important thing that you will be able to see, right? And that is nothing but the user information over here. Along with this, let me just hide my face. Here you'll be able to see that you'll be getting a launch button. Okay. So through this, you'll be able to access Canvas, I will be talking about Canvas as we go ahead in the further videos. TensorBoard, I hope everybody knows about TensorBoard. Profiler, but we are just interested in working on this particular studio, right? So once I probably click on this studio, and you will be able to see that I will be able to get this entire Amazon SageMaker. It will be a studio completely, which will actually provide you the entire ecosystem with respect to any kind of development that you really want to do. Okay. So here you can probably see Jupyter Lab is there. If you want to quickly start, deploy, fine tune and evaluate pre-trained models specifically for LLM, you can also go ahead with this. If you want to probably go ahead and do some kind of auto ML, you can also see over here, there is an option, model evaluation. So you'll find this entire ecosystem. Okay. Now what I'm actually going to do is that I'm just going to click on this Jupyter Lab, and right now you'll be able to see that nothing is running over here. Okay. Nothing is running specifically. And what I'm actually going to do, I'm going to create a Jupyter Lab. Okay. Over here, Jupyter Lab space, so that I will be able to work it. Okay. So here I'm just going to write test demo SageMaker. Okay. And this I'm going to show you with Huggingface. Okay. Huggingface models, right? So here it will first of all ask you to probably select the instance, right? Multiple instances you can probably select. For my use cases, again, this instances, if I go ahead and check over here, SageMaker instances, based on different instances, there is a different price. So you really need to be taking care of this, because see, if you're working in a company, based on the requirement, you can probably select the instances. So here you can probably see on demand pricing. So let's say if I select ML33 medium, $0.05, here it provides you CPU with 2 core, 4 GB memory. But understand, if you are specifically working with generative AI models, right, you definitely require a huge amount of data, right? Huge amount of space. So if you probably go further, there will be good amazing system accelerating computing, which also provides you not only CPU cores, but also GPUs, right? So as you keep on using more and more, you'll be able to see the charges will be going higher and higher. But just in this specific video, I really want to show you some demo. But again, if you just get this idea in any companies, if you go, you will be able to work it out, right? So I'm going to take a small system and probably work with this, right? Now, which small system I'm going to specifically take? So if I go up, here is something called as ML.M5 too large. So if you go ahead and see over here, ML of 2 large. So this is basically providing 8 core GPUs and 32 GB memory. The charges will be 0.461 price per hour for using this particular instance. The reason why I'm doing this is that because I will just give you an example of one of the model, how it is deployed and all. Okay. And we'll see to that. Okay. So here I'm just going to keep the storage to 10 GB. And now I will go ahead and click on run space. Okay. So once the run space is clicked on, you'll be able to see that my entire environment will be ready and I should be able to work it out. Okay. And with respect to this, any kind of code that you run, right? In my recent video, you have also seen that I have actually created entire one Lambda function with API gateway. I've shown you how to probably create the endpoint and all. So all those things you can probably do with this also. But here, more amazing endpoints, you'll be more amazing ecosystem and features you'll be able to get. Okay. So this is going to take some amount of time. So, okay, now it is created. Now I can just go ahead and click on Open Jupyter Lab. Now, understand with respect to Huggingface, there are multiple ways to load a specific model. Okay, there are multiple ways. All those ways I'm going to talk about, and this will be important for you because you really need to have an idea like how we can actually work in AWS system, right? So once this is loaded, the first step, okay, what you can do, I will just go ahead and change my theme. So I'll make it Jupyter Dark. Okay, so here you have options. You have options for notebook, you have options for console, terminal, Python, anything you can specifically work it. I will just go ahead and open notebook. And the first thing that I will do is that just go ahead and write pip install SageMaker, okay, which is the upgraded version. Just go ahead and install that. Automatically the installation will be taking place and all the recent updates that is basically there with respect to the SageMaker, that will get updated. And understand, this is my entire environment, the same Jupyter notebook that we usually specifically work on and all. So, right. So here you'll be able to see this. Now to go ahead with what we really need to do initially. So I will go ahead and import SageMaker. Okay. And there are some steps that you definitely need to follow as we start, right? So I'm going to import Boto 3. And I'll be providing you all the code in the description of this particular video. So first of all, we'll go ahead and create our session. The session will be nothing but sagemaker.session. Okay, sagemaker.session. So by default, whatever is the session, we'll be able to get it. Initially, we have not set up any session buckets or anything as such. You can also create that particular session. So I'm just going to write over here, even with some comments, so that it will be beneficial for you. So here you can see session, Sagemaker session bucket used for uploading data model logs. So if you want to probably upload data, upload a custom data, or download the Huggingface model in this particular S3 bucket and probably retrieve from that or use from that, you can actually do that. Sagemaker will automatically create this bucket if it does not exist. Okay, so you can probably go ahead and write this particular condition, and here you'll be able to see that if there is nothing as such, if it is none, I'm just going to probably make, if the session is not there, I'm going to probably go ahead and create the default bucket. Okay, so this is the code that we do initially, and this bucket will specifically be used to upload any custom data or training data. It can be models after the inferencing and multiple things. Now, other than this, we really need to focus on the role management over here, because since we are using AWS SageMaker to execute any kind of code, specifically by using the services of AWS SageMaker, we really need to provide the role access and all. So for this, we can just go ahead and write some try catch blocks. So here I'm just going to go ahead and write try, and let me just go ahead and do pass over here, and let me go ahead and write except block. With respect to this particular except block, I will just go ahead and raise some value error. And the best thing over here is that you'll get all the suggestion, right? And that is pretty much amazing, right? Once you're specifically using it. Let's say my IAM user is not yet set. So it will obviously give an exception. So it will go to this particular value error. And here I will first of all go ahead and set up my user. So I'm user in short. So I'll go ahead and write boto3.client. And I'm also checking out the documentation page. It is always good to probably check out the documentation page and perform in that particular way. And then I'm going to basically set up my role. I'm going to use im.get_role. Now it is going to probably pick up those role that is configured with this particular Jupyter notebook, right? So I'm just going to write role name, okay, is equal to sagemaker underscore execution underscore role. Okay, and this is basically going to be set up with our role, and from that we are going to probably take a ARN number, right? That is how we specifically identify the unique role that we are probably trying to give. Okay, so all this thing is done over here. Let me just make some spaces that is actually required whenever we work with this. Okay, so here you can probably see my role is also set up. This is my exception. Now let me quickly go ahead and write in a try once the role is set up. So I can basically go ahead and write sagemaker.getExecution role. Okay, this will be responsible in getting the execution role. If by default nothing is set up, then you can probably call it out based on the role that it has. Okay. Again, one common thing that I've seen that we have to provide spaces over here. So that is one of the things over here. So please make sure that you keep on working with respect to that whenever you're writing any code. After that, I will just go ahead and write session is equal to sagemaker.session. I'm just going to call my session, and here I'm just going to use my default bucket. So here one of the parameter that you can probably see is nothing but your default bucket, which will be assigned to my default bucket, or sorry, not default bucket, SageMaker session bucket. That is my default parameter that is specifically required. Okay, so this is the first step that you really need to do it. Okay, and then finally I can go ahead and print my, you can see how it is going to pick up the ARN role. Okay, SageMaker role ARN, and here I'm going to basically set it up to role. Okay, so this is the role that is going to get print up, and next the print is equal to, and here you can probably also go ahead and write your SageMaker session. So SageMaker session region, if I want to display it, okay, it will be nothing but session dot boto region name, right? So this is also there. So once I execute it, let's see whether it will be working fine. So here you can see not applying HTTP defaults. This is there, not applying info. Okay, some error I can probably see over. Okay, let's go ahead and do that again. Okay, now it's working fine. You can probably see SageMaker role is basically this. And this is the default role that the domain has basically created with respect to the user. And then US East one I'm actually working on. Okay. So this is the first step. Now, if I have the roles and all, now I can probably go ahead and call any kind of models that I specifically want. So first we will try to call one type of model, and I will just go ahead and show you the code. Okay. So here I'm calling one model which is called as Distill BERT Uncased Distill Squad, and this is specifically used for question answering. So I am basically going to give the hub configuration. See, Huggingface Hub, if you don't know about Huggingface Hub, then there you definitely have a lot of models which you can probably use for multiple use cases. So here you can see Huggingface model ID. I have to probably give whatever is my model ID, the kind of task that I'm looking for. I'll be giving in the form of key value pairs in this particular variable called as hub. Okay. Then we go ahead and create the Huggingface model, right? And for that, we have already deployed or imported from sagemaker.huggingface model, import Huggingface, right? And then finally, you'll be able to see that I'm using this environment hub. Okay, role I've already used, transformer version, which is provided, PyTorch version, and Py version 3.9. Okay, so this is how the parameters you really need to give with respect to this. Okay, so I've already executed this and I don't want to again deploy this entire model in my another Jupyter notebook because it is going to definitely take time. So just to give you an idea, I have already done that. So let me just show you over here. This is my another instance which I was actually working on. So here is my second Huggingface model which I have actually given. Third, how to deploy it to the SageMaker inferences. As you know, I have selected ml.m5 x large. Okay, so I'm writing predictor by using the same Huggingface model dot deploy. I'll be saying the instance count as 1. Okay, because I just required one instance. And what is the instance type? Instance type is ml.m5.x large. Okay, where I'm specifically deploying. Other than that, I need to make sure that how should I give my input. So I will be creating in this particular format because this model, that is distill based uncaged distill squad, will be requiring the input data in this particular format. That is question, what is the use for inferences, then context, my name is so and so. I've just given some examples so that my more charges should not incur, and then we'll go ahead and predict the data. So here you'll be able to see if I go ahead and write predictor dot predict. Okay, with respect to this particular data, because this data is required in that particular use case. So here you can see score is this one, start is this one, end is this one, answer is SageMaker, right? So what is used for inferences? So here you can see from this particular question, you have that SageMaker it is going to pick up. Understand when I execute this code, it is going to take 5 to 10 minutes to deploy into this, and you will be able to get your endpoint. Okay, just to give you an idea, how does an endpoint look like? I'll just go over here, just a second. How does the endpoint look like if you really want to see. So here if I go back to my SageMaker studio, I've created multiple endpoints. So if you go to deployments, you'll be able to see endpoints over here, right? These two endpoints are there. Let's say I want to go ahead and see this particular endpoint. Okay, I can click on this particular endpoint, and once we deploy it, that endpoint will be created. If I want to test the inferences, you'll be able to see that I'll be getting this application JSON, and whatever body I'm specifically giving, like how I'm giving over here, this is my entire body, right? And with respect to that particular body, if I give over here also and just test it, I should be able to get, if I just click on send request, I should be able to get my output, right? And there are also multiple options like auto scaling. You can scale to whatever things you specifically want based on the charges again. But here you'll be able to see that I have deployed this model in this particular instance, and you'll be able to just use that particular endpoint wherever you want in your code, anywhere as such, based on your requirement, right? So this was the entire thing, right? Let's try some more thing. Okay, I will again create some more data over here, and my name is Krish, and I teach data science. I'll just give this a, and I teach data science. Okay, so what does Krish like? Okay, I'm just going to execute this. Let's see whether I'm going to get the answer. Predictor.predict. So you have a predict method. Here you can see the answer is data science, right? What does Krish like? What does Krish teach? Also, you can basically do. Okay, you'll be able to get the answer, data science. Okay, so in short, this is just a simple model, right? I've probably deployed this particular model. You'll be able to see that this is my entire SageMaker, and here, it took some amount of time. I think this dots are like every 1 minute, around 6 to 7 minutes, to deploy this entire model in this particular instance, which I've actually created. Now, just to give you an idea, like how does machine learning or LLM model be like? So I'll be giving you multiple examples. So first of all, you have to probably go ahead and update SageMaker. The same thing by keeping your role and region name. Then you are basically going to call the SageMaker image URI, right? Since we are going to run it as a container. So here you can see Hugging Face deep learning container in AWS SageMaker. So the entire LLM model will basically be put in a container. Then you can actually call that particular container over here. So in order to call the container, you will be using from SageMaker.HuggingFace get Hugging Face LLM image URI. And then here is your version that you're specifically using and what kind of image you are actually coming up with. Okay, just to show you, if I probably give you an example, I will go ahead and install all this. Let's see. You'll be able to see the URI. Okay, and then it will probably download it and upload it. So there will be a lot of task in that, and a lot of money will be required, because again, at the end of the day, you are, see over here, you have probably got this. Now let me just execute this again. So here is your SageMaker role ARN. Then you can see that which URI I'm actually calling, right? So if I probably go and see, this is the URI that is basically required, right? Image URL. So if you know about Dockers and containers, so once you get the URI, then you should be able to load the Hugging Face model. Now, here also you can probably see, here we are calling Falcon B40B instruct. Number of GPUs, how much you want, and just imagine the instance type that we are going to use is MLG512 into large. I'll just show you the cost, and you will be pretty much shocked to see the cost. So here you can see internal storage GB is 1 into 3800. Total GPU memory is 96. GPU 24 core. Bandwidth, internet bandwidth is 40, and the GPU model is NVIDIA A10H. Right, memory is nothing but 192, CPU cores is nothing but 48. Just imagine how much the charges will be. So that is the reason why I have actually taken a small model and probably shown it to you. Later on, you can probably do with respect to anything once you probably go to the company, right? So that is the reason we have selected all these parameters over here. Then we initialize the Hugging Face model. Then we deploy it. That's it, right? And then after that, you can probably use that same payload. You can structure the payload over here with the prompt, and then you will be able to get the text. Okay. So anyhow, I will be giving you this entire examples in the description of this particular video. But again, yes, I've told that I've been uploading videos on AWS SageMaker and all, but definitely there requires a lot of charges that is involved, but it is always good to have a knowledge about it. That is the reason, that is the main aim for this particular video. So I hope you like this particular video. This was it from my side. Again, you can refer to multiple examples. Here, I will also give you this GitHub link from the documentation of Hugging Face. Guys, in this particular video, we are going to discuss an end-to-end LLM project with the help of AWS Bedrock and Langchain. This was also one of the most requested video from many people out there. What we are going to do in this particular project is that we are going to develop a document Q&A application, where specifically we'll be harnessing multiple models that are provided by AWS Bedrock, like Cloudy, Llama 2, and you can also use Amazon Titan. Whatever models you specifically want that actually it provides, we can actually use them and we can implement this entire application. So to go ahead with, I will just go ahead and show you the quick demo over here. So what is this specific entire application? This is a RAG, right? We are trying to create a RAG system wherein we have multiple PDFs. All those PDFs is stored in the form of vector embeddings inside vector store. And whenever we ask any query, we will be able to harness the power of AWS Bedrock, which provides different models like Cloudy, Llama 2, and based on this particular question, we can retrieve that question from the PDF files. So let's say I'm asking what are transformers, and if I go ahead and click on Cloudy output, that basically means it's going to hit the Cloudy API, Cloudy model, and I'm going to get the entire response. Okay, so currently this is running. If you probably want Llama 2 output, I can also go ahead and click on Llama 2. and I can actually get that specific response, right? So whatever questions you have with respect to this particular PDF documents, what the set of PDF documents also I'll show you, and you will be able to get the entire response over here, right? So why it is taking some time, because I still need to write that optimized version of the code. But once it runs, right, for the first time, I think then after that it works absolutely fine. Now let me just go ahead and write what is YOLO, right? So if I go ahead and click on Llama 2 output, before, see, I showed you also Llama 2 in my local system itself. Over there, it was taking a lot of time, but this is directly coming from the API model itself. So here is what is the response I'm specifically getting, and I'll be able to get the answers. Now, this is what I'm going to develop completely from scratch. Already, if you remember, guys, in our previous session, yesterday I had uploaded a video where I showed you the power of cloudy.py, how to invoke the model and all. Then we also saw with respect to Llama 2 and all. Now let me just go ahead and create a new file over here. So let me just go ahead and write this as app.py. Now inside this app.py, I'm going to write my entire code. Now, before I go ahead, I really need to do some installation with respect to some of the requirements. As said, here we are going to use not only Boto 3 and AWS CLI, we are also going to use some more libraries like PyPDF. So let me just go ahead and write this over here. So we require PyPDF. Along with PyPDF, we also need Langchain. And then we will also be requiring Streamlit, right? Along with this, we also require Fias CPU, right? So this is what we are going to use, because from our local environment, we are going to do the vector embeddings. So for this, I'm going to use the Fias DB, right? So through this only we'll be able to create the vector embedding into the vector store. So these are some of the basic requirements that I actually require. Now AWS CLI is also there because we really need to configure it. Now let me quickly go ahead and open the terminal. Let me clear the screen because yesterday I was creating the images over here. The first step, again, you have to create a virtual environment, do all this pip install and all, right? I hope I don't have to tell you all those things now because I've repeated many number of times. So let me go ahead and write pip install -r requirement.txt. If you are not able to understand it, guys, please make sure that I'll be providing you this entire playlist in the description of this particular video. You can go ahead and watch it. Okay. But you have to follow the playlist, right? Again, I'm not going to repeat everything from scratch. Otherwise, it is just a waste of time. Right. So till this installation is basically taking place, let me just go ahead and talk about what all things we are going to basically develop. Right. So this is the document Q&A search. So in short, my PDF will be stored in the form of my entire PDFs. We probably consider this. My entire PDF will be stored in vector store. And from this vector store, we can specifically query any information that we want. Along with this, we are going to harness the power of Langchain along with the LLM models from AWS Bedrock. Okay, so this is what we are going to do in this project. So please make sure that you prepare well, understand the architecture, what we are trying to do. So our entire project deals with two important steps, 1, 2, and before this, we are also going to do a very important step, which is called as data ingestion, right? Now in data ingestion, what we are going to do is that we are going to read from the entire folder, how many PDFs are there, all the PDFs, we are going to read it, okay? So once I probably get this entire PDF, then my next step actually starts over here. I'm going to take all those documents, the PDFs over there, split this into chunks, create the embeddings, and here we are going to use this Fias database. So here we are going to use this Fias, right? The vector database. And through that only we'll try to create this vector store, right? So step by step, I'll show you how to do this. What embeddings also we are going to specifically use here. See, understand, we are going to create the embeddings. So for embeddings, we are going to use, today I will show you a new model, which is basically called as Amazon Titan. Okay. So that you understand, you have multiple options. You may have implemented multiple options with respect to that. Because tomorrow in companies, if you go, definitely they are going to use this AWS Bedrock because it provides a lot of features, right? So for creating these embeddings, I will specifically use Amazon Titan. Other than this, if you don't want to use this, you can also use OpenAI embeddings, right? It is up to you. I've also shown with Google Generative AI embeddings, multiple embeddings techniques in my playlist with respect to Google Gemini and all. So after we create this vector store, now how we are going to use the LLM. So In the second step, whenever we ask any question, first of all, the similarity search will happen from the vector store. Whatever relevant documents and chunks we get, we have to take these chunks, give it to my LLM model along with the prompt. Like let's say that I say that, okay, please summarize this entire information based on the query that I've asked in 250 words. So this LLM model along with this prompt is going to take this particular data and it is going to give the answer itself, right? So this both I'm going to develop completely from scratch. Step by step, we'll try to see it. Okay. So let's quickly go ahead and let's start our coding without wasting any time. Okay. So here is my app.py. As said that I'm going to do it completely from scratch. So there will be some installation. There will be some errors that may be probably coming up. So we will try to also import all the libraries based on the pipeline that we have created, based on the steps or architectures that we have already discussed. So first of all, quickly, let's go ahead and import JSON. So I'm going to import JSON. I'm going to import OS. I'm going to import sys. I think I'll not be using sys, but let it be. These are some of the common libraries that we'll specifically use. Along with this, we are going to use Boto 3. And again, guys, in my previous video, I have shown you how to configure the AWS CLI. Please make sure that you watch the playlist. Otherwise, you'll not be able to understand. Okay, if you directly go into and jump in this particular video, no, you'll not be able to understand. So in the description, I will give you the playlist. The first video only I've shown you how you can actually configure the AWS CLI. Okay, so please make sure this. Okay, the next thing is that, as I said, right, we will be using Titan embeddings model, right, for creating vectors or to generate embeddings. Okay, so we will create this model. The reason why I'm showing you, because I've never used in any of my videos. Now this Titan embedding, what I will do, I'll call from the Langchain library or Langchain framework. Langchain provides you multiple functionalities, multiple options to probably interact with Bedrock, right? AWS Bedrock. So as I said, this framework is compulsory for you all to know. One is Langchain and LlamaIndex, right? So what I'm going to do, I'm going to write from Langchain dot embeddings. I'm going to import Bedrock. Let's see, BED Bedrock embeddings. Right, so I'm going to specifically use this. This will be small letter. Okay, so guys, I'm also verifying it from the documentation. Okay, so there is a documentation that is given, not very much clearly, but I have implemented this entire project also. Right, so from Langchain.embeddings, import Bedrock embeddings. The next thing that I'm going to use from Langchain.LLMs, like we can also use Langchain to call these LLM models that are present inside Bedrock. So that is also integrated, right? From LLMs dot Bedrock import Bedrock. Okay, I'm going to specifically use this two. One is from Langchain.embeddings, Bedrock embeddings, and from Langchain.LLMs.bedrock, I'm going to import the Bedrock. Okay, so this is specifically for the embedding part. Okay, now there will also be some libraries that I need to import for data ingestion, because I really need to load the data set, right? So over here, you'll be able to see I will write import NumPy as NP. Okay, this is NumPy I'm going to specifically use, but I think by default NumPy will be available. Import NumPy as NP. Perfect. So NumPy as NP. Then from Langchain dot text splitter, I'm going to use text splitter, so that as soon as I load the document, I need to probably use this recursive character text splitter. Okay, so this is what we specifically use, and in my Langchain series I've discussed everything about this. Then again I will go ahead and write from Langchain dot document loaders import. We will specifically use this py. So let me just copy this py-pdf directly loaders. So this is what we are specifically going to use, py-pdf directly loaders, and it is actually present inside Langchain.document loaders. Okay, so this is specifically required for the data ingestion. With this, what I will do, I have already created one folder over here which is called as data, which has these 2 PDFs, right? I need to load all these PDFs from this particular folder and then perform all the vector embeddings that I require. So in data ingestion, first of all, we will load it. We will split the entire documents by using recursive character text splitter. And then after this, we will convert this into vector embeddings. So let me just go ahead and write vector embeddings and vector store. Here I'm going to specifically use FiasIndex, okay? FiasDB or ChromaDB also you can use. It is up to you. Again, I've shown both the ways in my playlist. So from Langchain, let me just see this. Okay, so Bedrock embeddings. Is there something called as from Langchain _ community? It was, right? Let's see. Okay, from Langchain _ community. Let's copy this. Is this correct or not? We'll try to see. Yeah, Bedrock embeddings was there. Let's copy this here also. So PyPDF directory loader is also there. I think there will be some warnings that will be coming. I think some of the libraries Langchain community. Okay, so here what I'm actually going to do from Langchain. Let's see if we get an error again. I'll revert it. Okay, from Langchain.text splitter. Sorry, not text splitter. Why I'm using text splitter? Already I've actually done it. So I'm also going to use for this vector embedding specifically. I have to use vector Fias, right? So I will write vector stores import Fias. Okay, so Fias is one library I'll be using. Again, this Fias will be present inside community, I guess. Okay, so vector Langchain _ community dot vector stores import Fias. Let's see, Fias is not accessible, so I think it is inside Langchain only. Okay, otherwise you can see the documentation. Okay, at the end of the day, no worries. Then after doing this, I will also write from Langchain dot indexes. Okay, I'll not use this also. Let's just use Fias because we have already installed Fias CPU. Okay, then after doing this, what we are specifically going to do is that now this is for the vector embedding. Now we need to go ahead with the LLM models, right? So for LLM models, the Langchain already provides ways to load models from the AWS Bedrock. Okay, so for here I'll write from Langchain _ community dot one. I will specifically use prompts. From Langchain dot prompts, I'm going to import prompt template. Okay, and then the other one is from Langchain dot chains. I'm going to specifically use one chain where I'll be using import retrieval QA, right? So since I'm going to create a Q&A chatbot with the documents Q&A in short, so that is the reason I'm using this, and this is basically to create my own prompt template. Now let's call the Bedrock client so that we get the access of all the models. Okay, so I will go ahead and set up the Bedrock clients over here. So here let me go ahead and write Bedrock is equal to boto3.client, and here I'm going to give my service name is equal to Bedrock dash runtime. Okay, so I've already shown you yesterday also in my playlist of this Bedrock. I've also shown you how you can actually call the client itself and access the models. Okay, now as said, as I already told that the embedding that we are going to specifically use is called as Bedrock embeddings, right? So let me quickly go ahead and call this. I will go ahead and write Bedrock embedding, and let me show you how you can actually call this embedding from the AWS Bedrock. So I will copy paste this. Let me give the model ID. Now this model ID, you'll be able to see it over here, right? So if you probably go ahead in AWS itself, let's say I will go ahead and write embedding. Okay, so here only in Titan, I think you will be able to find it out. So foundation model, base models. So if you go ahead and search inside this, any of the embedding models you can specifically take, but I'm going to use this Titan embedding model. Okay, so if you probably click over here, and see down, you'll be getting the entire details, like what is the embedding, what is the model ID and all. Okay, so I'm going to specifically use this. So let me quickly go ahead and call this model ID. So for this model ID, I've already copied it from that this particular website. So here you can see I will have copied this entire thing and I will paste it over here on my model ID. So you also have to do the same step. Okay, so once we do this, the next thing in this that we really need to give is the client. And client, you know that we have not yet called any client or what. So we have called this Bedrock client. So this will basically be my client over here, right? So once we give this Bedrock client, that basically means it knows we are going to call this particular embedding model from this particular client, that is Bedrock itself. In short, we are going to use the AWS LLM, AWS Bedrock. Now, let me quickly go ahead. And this is what is all step by step we'll be going. First, we will create this data ingestion model. See, if this step is done, we have created our client. Now we will go ahead and implement this data ingestion. So quickly, let's go ahead and implement this data ingestion. And please make sure that you follow this. So here I'm going to basically write data ingestion. Okay. And I will create a step which is called as data ingestion, a function. Now inside this data ingestion, what things we are specifically going to do, right? I have a folder. So let me go ahead and write loader is equal to py-pdf directly loader. And here I'm going to give my folder which is called as data, right? From that data folder only, I need to pick up all the PDF files, right? So this is the first step. Then I will go ahead and write documents is equal to loader.load, right? So from this loader, we are going to load this entire documents. Now, in our testing, we will specifically use something called as character text split, right? So that is what we have already implemented, right? Recursive character text splitter. Now, how do you implement this? It is very much simple. I will go ahead and write text splitter, right? And this with the Langchain, I have already shown you. So it will be recursive text splitter. And here, first of parameter will be my chunk size, chunk underscore size. Chunk size, I will give it to 10,000, right? And along with this chunk size, the second parameter I would like to give as chunk overlap. Please give this number a little bit more value so that you will be able to understand it. Okay. So these two are there. Text splitter, recursive character text splitter, and this, right? Once we get this text splitter, I will go ahead and write docs is equal to text splitter dot split underscore documents. Okay. And then here I'm going to give my entire document. So in short, we're going to split it, right? Based on this recursive character text splitter. Once we do this, then we will return the docs, all the docs. We're going to specifically return the docs. So data ingestion is done, right? With respect to this particular data ingestion, here what we are doing, we are reading all the PDFs from the data folder. We are doing recursive character text splitter with this chunk overlapping. And then we split all those documents, right? So this completes our data ingestion. Now the next thing is that we will go ahead with vector embedding and vector store, right? And this is where we are going to specifically use that Titan embedding that we have imported. Along with that, what we are specifically going to do is that we are going to use this fires, right? So let me quickly go ahead and write it down. So here I'm going to write my definition. And quickly, let's go ahead and write get vector store. So I'll create one more function. Now inside this vector store, I'm going to first of all give the documents, whatever documents is coming from here, because we take these documents and then we do the embedding techniques and we perform all the embedding techniques. So in my next step, what I will go ahead and write, I'll write vector store underscore fires. Okay. So this will basically be my variable. And then I'm going to use fires dot, okay, from underscore documents, right? And we are going to implement this, right? So in the first parameter inside fires, we give docs, and the second parameter that we specifically give is my Bedrock embeddings, right? So this is the embedding specifically we are going to use. Okay. One is the Bedrock embedding, which we have initialized over here. See over here in the Bedrock embedding, we have initialized, and that is what we are going to use it over here. Now, after we get that vector store fires, this is basically my vector store. I will go ahead and save it in my local disk. So let me quickly right, dot save underscore local. And inside this, we are going to basically write fires underscore index, right? So this will basically be saved in my folder over here itself, right? In my hard disk. You can also save this in any database as such if you want. So this is my vector embedding. I've done it. And this step is also completed. Now let's talk about the next step. In the next step, based on the import, we have to work with LLM models. Now what we are going to do over here is that I'm going to create some LLM models. Let's say I will go ahead and write first LLM model that I'm going to work with is Cloudy, right? So I will say Cloudy LLM. And inside this Cloudy, we will create the Anthropic model, because I should see already AWS Bedrock is giving you the power to harness multiple models, to use the multiple models. So we can specifically develop in this application itself. It's just like having different models in different ways. But here I'll try to make it much more generic. So here we are going to create the Anthropic model, and I'm going to create my LLM. Along with this, we are going to use this Bedrock. So Bedrock, before, if I probably show you in my previous tutorial, the way of invoking a model was something like bedrock.invoke model. But now since we are already using Langchain, we don't have to basically use invoke model. So what we specifically do, we just call this Bedrock, and you can probably see how for where this Bedrock is present. It is present inside Langchain. So they have actually created a wrapper, and internally they will invoke that specific model. But this is a way that how you can use this frameworks like Langchain in a generic way. So now I'm going to use this model as Bedrock. Now, with respect to this, I will go ahead and write my model ID. Already I have searched my model ID. So this is what is my model ID over here. How do you get this information? Again, from this particular examples, go and click on any model. You will be able to, let's say I want to generate generate code. So with respect to this, this will be my model ID, right? So it is a generic way of finding the model ID. So you don't have to even worry about it, right? So I have my model ID, which I did it in my previous tutorial also. And then I will go ahead and write my client. My client will be nothing but Bedrock. And the next thing that I'm going to specifically give after this, right? One is model arguments, right? So model arguments with respect to this. Now this arguments that you'll be seeing, right? Where do you find it again? If you probably go over here inside the body, and if you go at the last, right, there will be some arguments that will be added like this: max tokens to sample, temperature, this. You can also add it over here. Now with respect to this particular model that I am actually using, this was the argument that was present inside that particular body. So that is the reason I had created this, right? All this JSON file separately so that I can refer it. Okay. So I hope you are able to understand it. If you are able to understand, please make sure that you hit like till now. And now let's go ahead, and here what we are specifically doing, whenever I call this function, that basically means my Cloudy model has got loaded. So I'm going to return the LLM model. Now suppose similarly you want to probably go ahead and call the Llama 2 model. So I will go ahead and paste it over here. I'll say get Llama 2 LLM. Like this, you can actually create any number of functions as you want. Okay, so this will basically be my Llama 2. Now inside my Llama 2, let me just copy this. Again, I'm going to see so this is the Llama 2 model over here. Okay, only the model ID change, and whatever is the argument that will change. So in the case of arguments, with respect to this is nothing but max gen length, right? How I'm getting it, let me show you again. Okay, so let's say this is chain of thoughts. Let's say that I'm going to use this. Okay, so here you can probably see this is my model ID. Okay, and then inside my arguments, this is from where we'll be able to get it, right? So this API request is pretty much important with respect to this. Okay, so return LLM model, and this is where is my LLM model that I'm getting with respect to Llama 2. So now you know how to create, how to call any models itself, right? Data ingestion is done, vector store is done, everything is done. Now let's go ahead and create my prompt template. Now this prompt template that I'm actually going to create, I'm going to use something called as Langchain. So in my prompt template, I've written, see this, okay? So I've given a simple prompt template, which you can also use it. So I've written human in this format. Use the following piece of context to provide a concise answer to the, and at least summarize with 250 words with detailed explanation. If you don't know the answer, just say that you don't know. Just don't try to make up the answer. So context and question is there, and based on this assistant, whatever assistant output is there, it will get appended over here. Now with respect to this particular thing, we use the Langchain prompt template. We write context and question and we use it. Okay. Now this is fine. Everything is good. Now let's focus on the response part. So here I will go ahead and write get underscore response underscore LLM. And here the first parameter is my LLM. The second parameter is my vector store fires. The third parameter that I'm going to give is my query, right? So these three parameters we are going to play with. One is obviously if I want to get the response from a specific LLM, then I have to give this three information. Okay. Get response LLM, the LLM model which I'm calling. This is my fires index and this is my query. Okay. Now once we get this, as you know that we have imported something called as retrieval QA. So retrieval Q&A here also we are going to use it, and this is how you basically call it, right? So I'm just going to copy it, paste it over here. Again, I'm seeing the Langchain documentation. So retrieval QA from chain type, I'm giving my LLM model. Chain type will be stuff. I've already shown you what is text summarization, different text summarization techniques. So stuff is there. Over here, this is the most important thing, retriever. How, from where the similarity search will basically happen. So this is where we are doing, right? Our fires index basically has the entire index itself, right? And then we are trying to do the similarity search along with the argument top K3 or top 3 prompts. And then we are also saying return source document with respect to this one. And then I have my prompt over here, right? So all these things are basically done. And then after this, we will be able to get the response. So now once we specifically write this chain type arguments, and here we are specifically giving the prompt is getting created by the prompt template over here. And then in the next step, we will go ahead and write answer. I'll create a variable called as answer, and we can use this QA variable. And inside this, we will give in the form of query colon, and here we are going to give the query itself. So this query is the query that is coming from as an input. Okay. And once we get the answer, see when this QA is basically using, right, it is nothing but retrieval QA. So it will retrieve the response and it will store it in this particular variable. Now inside this variable, there will be something called as result as a key, which will give you the output. So if you print it, right, initially I printed this answer. I've already implemented this. So there is a variable called as result, which has the entire answer. So this is my response LLM where I'm getting the entire result. Now let's go ahead and create our Streamlit app. Now quickly, there are two important things with respect to this Streamlit app. One place, I have to make sure that whenever a document is updated, that it should get converted into a vector embeddings. So what I'm actually going to do quickly over here, I'll create a main function and let me show you what I will be doing. Okay. So quickly, first of all, I will import Streamlit as ST. Streamlit as ST. Fine. We are going to use Streamlit. Now see this. The thing that I've copied and pasted. So I've written chat with PDF using AWS Bedrock. This is my user question, like what kind of question I want from the PDF file. Then a sidebar is basically created, and I will say update or create vector store, right? That basically means inside this, I will create a button saying that vectors update. That basically means once I click, right, then it should go ahead and call this data ingestion. Now data ingestion, what it is going to do, this data ingestion is going to read all the files from the data folder. Then it is going to take this documents. It is going to perform this recursive character text splitter. And then after doing this, it is going to return this entire documents, right? After this, we are going to call this vector store. So one by one, we will be calling it. So here you'll be able to see data ingestion and vector store we are calling. We get this docs. Now inside that vector store, what is happening is that we will save this in our local folder itself in the hard disk in the form of fires index. So as soon as I click this button, that is vector update, which will be available in the sideways inside the sidebar. Sidebar means in Streamlit it is in the left hand side. So the vectors will get created, the vector stores will get created, and it will also saved in a local folder itself, right? So over here, a folder will come with this particular name that is called as FireIndex. This is one step. Now the second step is that I can go ahead and create a cloudy output. Okay, I will create a button which is called as cloudy output. Now see this is important to understand. Okay, so this is my button. I've created another button. When I say cloudy output, that basically means I have to use the cloudy model API. So the first thing, as soon as I click on the cloudy output button, my files should get loaded from the local. So that is the reason I'm writing .load_local with this FireIndex and the Bedrock embedding, the same embedding which I've actually used. Then I will go ahead and call this cloudy LLM. Right, I'm going to call this cloudy LLM because I will get the LLM itself. Now, if I go inside this function, if I go ahead and write F12, okay. So here you will be able to see where it is cloudy LLM. So cloudy LLM, it is going to call this particular model and return our LLM over here, right? So here I'm going to get my LLM with respect to this, and this LLM will specifically be used inside this function, that is getResponse_LLM, where I have given my LLM, vector store fires and query, right? When I get this three information over here, I'll get my response, and I am writing this particular response over here. Very much simple, very much easy, right? So let's execute this and let's see whether this is working fine or not. Okay, so this is my main function. So what I will do, I will create this if__name with respect to this main. Now let's see whether we will get any error. Okay, so I will clear my screen. But in short, we have executed each and everything, right? So I will go ahead and write streamlit run app.py. Let's see whether we will get any error first of all. Okay, it's working fine. I will close this. Okay, now this on the left hand side, I will get this vector update or create vector store. And here I have chat PDF using AWS Bedrock. Okay, now the first step, as I said, what I'm going to do, here is my data folder. It has this PDF file, attention.pdf, yolo.pdf. So what I'm going to do, I'm going to probably click on vector update. As soon as I click on vector update, now what is going to happen? See over here, as soon as I click on vector update, what is going to happen? So if this is clicked, that basically means the data ingestion folder it will go. It will read both this PDF and then it will convert that into vectors. And we will save that vector over here. Right now you cannot see any folder in the name of FireIndex. But now if I go ahead and click on vector update, now what is going to happen? See, as soon as this vector update will finish, now processing is basically happening. And this will probably come up with like done. Okay, done status unless and until we don't get any errors. Let's see with respect to this, right? What will happen? So it is now loading all the PDF. It is performing, it is converting those into vectors, right? And then it has now stored that as a FireIndex. Now, if you probably go over here and see this folder, my FireIndex has created. It has index.fires and index.pickle, right? Now, this is the first step. Now, the second step is another button, which is basically cloudy output. Now, cloudy output is over here. Now, if I give any prompt, what is attention is all you need? What is attention is all you need? Okay. If I go ahead and click on cloudy output, now it is going to call the cloudy model, right? So if we probably go ahead and see the code again, what is basically happening? First, we will load this FireIndex from the local. Then we will call the cloudy LLM model. Then we will call this getResponse_LLM where we are giving all this three information, the user question. And now finally you'll be able to see I'm getting the output, right? Now this is with respect to cloudy output, right? So similarly, if I go ahead and write what is YOLO, I will go ahead and click on cloudy output. Now again, see, follow this pattern. Inside it will go, again it will load this FireIndex, right? And then we will call this particular cloudy model. Now how the performance can be improved? This FireIndex I will not call each and every time. So let me do one thing. Let me call this once, okay? Let me do one thing. For the first time, I will just keep it outside this. Okay, but again, it will give us an error, but I will give you that as an assignment. First of all, let's work on this. Okay, so here you can see my YOLO is also coming. Now see, if I want to add Llama 2 and all, what I need to do? I will go over here. My Llama 2 function is already created. If you remember, see over here, my llama 2 function is where? Get llama 2, right? So I will create another button. I will copy it like this. If my st.button is llama 2, right? So this will be my llama 2 output. Now instead of calling get cloudy LLM, I will say get llama 2 LLM. So now we will go ahead and check whether for llama 2 it is working fine or not. So I will save this quickly. I will see now. I'll click on llama 2. Now let's see whether we'll get the output or not. Again, the same thing is going to happen. First of all, it is going to load the Fires index. After that, it is going to take the LLM model. It is going to give all the information, and then finally you'll be getting the answer. Similarly, I can go ahead and write what is attention is all you need. Okay. So if I go ahead and click on llama 2, then again, I will be able to get the response. So this entirely, everything is basically happening with the AWS Bedrock. So step by step, I have shown you almost everything, the data ingestion step, what all libraries are specifically getting used, all this code, I have written it in front of you, the Streamlit file we have actually created. I would suggest go ahead and try it from your side. And this is how you're able to get the response. But the best thing is that all these models are available in AWS Bedrock and it is already scalable. You can actually use it according to your wish. So guys, as we know that we are learning generative AI specifically in the AWS cloud. So today, one amazing productivity tool that we can specifically use, which is I think available for everyone, and the name is Amazon Code Whisperer. So this is the page. We'll talk more about it, but if you just want to know what exactly Amazon Code Whisperer does, it's very much simple. I hope everybody has seen GitHub Copilot, where it provides general suggestion with respect to different kind of codes and all. So similarly, you can also use Amazon Code Whisperer, which is also now called as Amazon Q Developers. Okay. And this you can probably use to again get all the suggestion with respect to various codes and all. I will show you in this particular video how you can enable it in your VS Code, and trust me, this is an amazing productivity tool altogether to do your work very much faster and quicker. At the end of this particular video, since I have used both GitHub Copilot and Amazon Code Whisperer, that is nothing but Amazon Q Developer. So I will be making a brief comparison about it. Most of the functionalities overlap, but if I talk about Amazon Q Developer, it is specifically for some purpose. So when you are actually developing, and let's say you are probably using AWS account a lot, you are doing all your work specifically to AWS, then Amazon Q Developer will be the better code suggester for you. Okay. So let me just go ahead and show you how you can probably enable it. For enabling it, it is very much simple. What you really need to do is that just go to the extension, right? And just search for Amazon Q. Okay. So Amazon Q over here, if you're probably suggesting, if you're searching, you'll be able to see this. Right now, I have already installed it, and you can also install it. Let's see whether there is something called as Amazon Q Developer also. I hope so. We find it out. If it is not there, then we can specifically use Amazon Q. So this is the extension that you really need to install. And understand, once you probably install, in the left hand side, there will be a box that will probably be opened, wherein it will be asking you for the information regarding your AWS account, where you really need to log in just. And trust me, no credit card will be also required. You just go ahead and log in into this particular account with respect to your own personal email ID. It is also called as AWS Builder, which will specifically provide you the access to Amazon Q. Okay, so there will be a page that will be probably coming up over here. It will ask you for the username, password, and it will tell you to authenticate from the AWS account itself. So once that step is specifically done, then what you can do, you can just go ahead and exit this particular notebook and exit the VS Studio and restart it. Okay. Once you probably restart it, now you see the power of this. And as I told you, right, I've been using both GitHub Copilot and this one, that is Amazon Q Developers. Trust me, both of them works amazingly well whenever you're specifically writing the code. So just to give you a demo, right now my extension is enabled, and definitely use this for your coding purpose. It will be very much helpful also. So first of all, I will go ahead and write down the comment. Let's say write me a Python code, or write me a function to perform. Write a Python function to perform binary search. Okay. So I'm just asking one simple binary search. Okay, now this is the comment that I've written. Now you can see Amazon Q is generating. Right now it does not show you something right over here. And also it depends on internet speed, both respect to kind of suggestion and how quickly it also gives you. So if I go ahead and just write definition over here, and you know that the function is going to get created, automatically just press tab and all the entire suggestion will be in front of you, right? So just understand like how good the productivity basically becomes, right? If let's say for the first time I'm planning to write this particular function, right? Obviously I'll do some amount of Google search. Yeah, I'm lazy. I'll not remember each and everything, and definitely unless and until there is not an interview, I think you will also not remember it, right? So over here you can see that just by writing a comment and probably doing it, automatically all the suggestion is probably coming up, right? So this is really amazing, right? Let me just go ahead and do one more thing. Okay, some more complex thing related to generative AI. Okay, provide me a Streamlit app to call OpenAI APIs. Okay, so let's say I am going and writing like this. So the first thing is that I will specifically go ahead and import Streamlit as st. Okay, now let's see, import OpenAI. I'm not doing it anything. All the suggestion is probably coming from the Amazon Q developer over here, right? So same thing has got imported, but I think that part you can probably fix it. If it is not providing any suggestion, that basically means it is telling you to give one line of code, one line as an empty space. And again, now see, if it is not suggesting you something, just press enter, go to the next line, and again it will start suggesting you, right? So there it has probably created this message variable. And now I think if generated, session state also it is basically using, which is quite amazing. Okay, okay, past sessions, everything over here, it looks good. Again, same thing, I think. No, this is also making sure that I think it is also saving this prompt in the session state. Let's see. If user not in session state, how can I help you? Okay, perfect. I think this should be working fine. But again, unless and until I don't execute it, there will be some amount of errors that will specifically be there. Now see, now what this has basically done is that it is mostly hard coding things over here. Mostly hard coding things, right? With respect to my name is ChatGPT and all. So I think it is not doing that amazing job. But with respect to GitHub Copilot that I found, right, it was able to give me a good response. And that is where I'm going to make a lot of comparison. Okay, so let's do one thing. Let's remove this. Again, I think it is in that hallucination mode. Okay, let's go to the new line, or let's come after this particular function. Let's see what suggestion it will probably give us. Okay, now finally it is probably given this entire generate response function. What you can basically do is that I think I'll not use even this session because I just wanted a simple this one, right? So this is the function that I've actually created, and you can also guide it, just not based on the suggestion. You should probably go and just press tab, right? So generate response is over here. Here it is specifically communicating with text C02. Let me do one thing. Let me also go ahead and make sure that create this OpenAI API key. Okay, let's see, OpenAI dot API underscore key, and I will probably go ahead and set my API key over here. After setting this particular API key, let's see what kind of suggestion more it gives, right? So this is my messages, return message. Okay, so perfect. I'm getting from this particular function my entire message. This is my main session state, again session state, then again this message is append. Okay, perfect. It is appending, right? It is appending with respect to the different roles and all. So with some amount, but see, at the end of the day, I'm not writing much code. And again, what we see and why it is not that better when compared to the GitHub Copilot, because I'll tell you a specific reason why it is not. Okay, let's try one more thing. Okay, so here I'm going to write a comment. Now see how the performance of this particular code will become better by using Code Whisper or Amazon Q Developer. Write a Streamlit Python code to invoke AWS Bedrock foundation models. Okay, I'm just going to go ahead and write this, right? Let's see. Import Streamlit as st. Import Boto3. Okay, perfect. It is coming up. Okay, Perfect. st.title, again a streamlit, get the model name from the user. Perfect. So enter the model name. Okay, I will enter the model name, what model name I specifically want. Enter the input data. Okay, I'm splitting the data. Then input data will be this. Let's see what it is trying to do. Let's see. Input data. Finally, I get over here, print input data, invoke the model. Okay, perfect. See, Boto3.client is basically used to invoke SageMaker runtime, or you can also use it for AWS Bedrock. Okay, so model name, body input, what I feel it is good enough, get the predicted output. See, with respect to the Boto3, we can basically just change this. Instead of writing SageMaker runtime, I can write Bedrock runtime. Okay, so predicted response body, good enough. And this is basically my predicted output. I guess so, it is right. Enter the model name, enter the input data. So some amount. So here you can probably see the code is well structured. And what I feel is that, see, when I probably write a code, and if you have seen my AWS playlist where I'm specifically using Bedrock, right? You can probably see it follows most of the similar structure. So if I probably create a function, if I try to write it much more in a better way, and I cannot just depend on the entire application on this, right? So here it has done a pretty good work, right? And that is where, see, why with respect to only AWS work it is doing well, because this entire product is from Amazon Q developer is belonging to AWS, right? So just to make a brief comparison, right? Or let's see, I'll just try it like this. Okay, define a function to invoke AWS. Now see this Bedrock models. Okay, and that is where you'll be able to understand. So I'll write definition. Okay, and I will try to create a definition where I'll say call Bedrock model. Done. See this? Automatically all the things are done. Only the thing that I really need to change, Bedrock model endpoint, define the endpoint, SageMaker runtime. Instead of writing SageMaker runtime, I need to also give the model name. So model input is over here. I have to probably create this payload from my side, which is nothing but the same model input, which I will be providing into this particular function. Now, just to make a brief comparison between GitHub Copilot, you should understand that GitHub Copilot is specifically used for general purpose, and I also have that specific access. If I probably consider Amazon Q developers assistant that we have, code assistant that we specifically have, it is used to do, or it provides you good suggestion with respect to any kind of AWS task that you are probably doing in AWS itself. So just to make this brief comparison, so always try to make sure that it is good that you should know this, but again, at the end of the day, which is the most generic model, GitHub Copilot, that is a kind of suggestion that I would like to give you to. Both are trained in huge amount of data, but definitely if I talk about Amazon Q developer, it is your generative AI powered assistant across specifically to most of the AWS services.